So our final version of quadratic problems involve number puzzles. So these are more with the translating, but I've given us a bit of a boost by giving us the expressions to represent different numbers. So these are really about translating some words into an equation and then solving that equation using the quadratic formula. So the product of two consecutive integers is 72. So off the bat here, product implies multiplication. And the two integers, this is going to be the first. This one is going to be the second. So if I multiply these two together, that should equal 72. So I would have x times x plus 1 equals 72. I need to make this look like a quadratic, so I'm going to do distributive property. I'm going to set it equal to 0 by subtracting 72 from both sides. And then I have the raw material to put into the quadratic equation. This, by the way, is solvable by factoring as well, but we'll just keep it the same. So -1 plus or minus square root of 1 squared minus 4ac all over 2a. Making this look a little bit tidier, I'd have -1 plus or minus. Everything under that radical sign is 289. If I hit the square root button, that works out nice and neat and easy. So I'd have the positive option here as plus 17 and divided by 2, and I'd have the negative option here as -1 minus 17 divided by 2. I could have that x equals 16 over 2, which is 8, or x equals -18 over 2, which is -9. Now, every other question, we have been rejecting this negative option. In this particular question, there's no reason to reject this. We are going to go back to the two statements that we had for the first and the second number. So we know that we've got x and x plus 1. So we'd have 8 and 9. Or, remember we're entertaining both of these options. If I go to x and x plus 1, I'd have -9 and -8. So these are my options. So the numbers are 8 and 9, or -9 and -8. If we think back to what the question's saying, our answer is supposed to multiply to give us 72, and both of these would multiply to give me a positive 72. So one of the few cases where we're not ignoring one of our answers. Let's take a look at the next one here. So this one says the sum of a number and that number's square is 42. So x is going to be the number. This is addition. Its square would be x squared is 42. This doesn't quite look right as far as being in quadratic form. I can rearrange this, and I'm going to subtract 42 from both sides. This now gives me the information to put into the quadratic equation. So in this one, x would equal -1 plus or minus the square root of 1 squared minus 4, didn't put the brackets in there, ac all over 2a. Cleaning this up a little bit, using my calculator on everything that's underneath that square root sign, I get 169. And I can take the square root of 169, which is going to give me my two options. So x would equal -1 plus 13 over 2, or x would equal -1 minus 13 over 2. This is going to give me that x equals 6, or x equals a negative 7. And there's nothing wrong with having the two options here. The number are either 6 or negative 7. The number is, I should make that, fix my grammar. Whoops, erase. Number is, there we go. And that should make sense. So we'd have 6 plus 36 is 42. Negative 7 plus 49 is also 42. We can take it back to the original and it should make sense. Two more that are like this. So this one gives me some information. It also tells me that I'm looking for two integers. If you remember, integers were whole numbers, negative or positive. So we've got x and 2x minus 3 for the numbers. I've done the translating for us. If their product, this again implies multiplication, is 35, find the two integers. So if we take x and multiply it by 2x minus 3, that should equal 35. This doesn't look quite right yet. We need to make it look like a quadratic. I need to set it equal to 0. So I'd have 2x squared minus 3x minus 35 equaling 0. I can now plug this into the quadratic. So negative b plus or minus b squared minus 4ac all over 2a. Do some work on what's underneath that square root sign. When I do that, I get 289. And taking the square root of that is a nice neat number. So that gives me my two options. I have the positive option, so that's 3 plus 17 over 4. And I have the negative option, so 3 minus 17 over 4. If I keep going with these, just going to scroll down a little bit, give myself a bit more space, I get x equaling 20 over 4, which is 5, or I get x equaling negative 14 over 4, which is x negative 3.5. So there's nothing wrong with having a negative here, but take a look at the other limitation of the question. It says two integers. We need a whole number. This would not be an integer, so we'd have to reject that answer based on that piece of like math trivia. So the integers are based on this x, but we've got x as integer 1, and then 2x minus 3 as integer 2. Can't spell integer. So we'd have 5, and then 2 times 5 minus 3, or 7 as my other number. So the numbers are 5 and 7. Several steps on these. I do think that knowing where to start is sometimes the tricky bit. Usually you're okay with the quadratic, even though they can be a little messy. The next one here says the square of a positive integer, so that's going to limit my answer, is 56 more than the integer. So the square of an integer is 56 more, so plus 56, than the integer. So the x is the integer. And we'd have x plus 56 on this side. Making this look like a quadratic, I'd have x squared minus x minus 56 equaling 0. Hopefully I didn't lose you. We now have a clear vision of what we can do for the quadratic. X would equal negative b plus or minus the square root of b squared minus 4ac all over 2a. Cleaning this up a little bit, Grabbing my calculator to figure out what's underneath that square root sign, I get 225. This gives me the two options. So x could equal 1 plus 15 over 2, or x could equal 1 minus 15 over 2. Well, this one's going to end up as a negative number. I had said that there was a restriction on this where it should be positive, so we're going to reject that one. So x could equal 8. So the integer is 8. Definitely some tricky bits in there. On the test for this, there should be enough choice for you so that you can, play to your strengths. And I've tried not to give tricky questions, but you just never know. Sometimes it's that translation bit that is tricky. So these are our applications, and this is the end of Unit D.